Hey everyone, welcome to today's video. In this tutorial, we are going to learn how to create a simple voice recorder using Python. This will be a great project for beginners to get started with both Python programming and working with audio. We'll go through the code step by step, so don't worry if you're new to programming. I'll explain everything in detail. Before we start, we need to make sure we have the right tools. You should have Python installed on your computer. If you don't panic. Just search for Python download online and you'll find easy instructions. Once you're set with Python, open up your command prompt or terminal and type pip install pyaudio to get the extra library we need. Okay, let's open your favorite code editor. I'm using PyCharm. At the top of our code, we're going to bring in some special tools that other smart people have built. These tools are called libraries. We need two of them. PyAudio for working with audio and Wave for working with audio files. Now, we need to prepare the environment for our recording. Think of this like setting the stage for a play. We're telling the computer things like what kind of audio we want, how many actors or channels will be speaking, just one in our case, how fast the play runs, the sample rate, and how much dialogue to capture at once, the chunk size. Now let's set up some key parameters that will define how our audio is processed and recorded. Format. Audio data can be stored using various formats, and PyAudio int16 signifies that we're using 16-bit integers to represent the audio samples. This determines the quality and precision of the audio. Channels. This parameter defines whether the audio is mono, one channel, or stereo, two channels. In our case, we're using one channel for mono audio. Rate. The sample rate is like the speed at which audio is captured. A higher sample rate means higher quality audio, but also more data. Chunk. This determines how much audio data we capture in one iteration. Larger chunks can improve efficiency but might introduce latency. Let's get ready to record. Time to get the recorder warmed up. We're going to use the PyAudio library to make this happen. We'll create something called an audio stream. It's like turning on a microphone and saying, "Hey, listen up." Now, let's create an audio object that will enable us to interact with audio streams and perform various audio operations. Here, we're using the PyAudio.PyAudio constructor to create an instance of the PyAudio class. Think of this instance as our tool set for working with audio. It's like having a toolkit filled with different tools to perform audio tasks. And here's where the action begins. We're going to start recording. Picture it as hitting the record button on your phone. We open the audio stream with all the settings we decided earlier. We're opening a stream that connects to our microphone. This is where the magic happens. Here, we are using format equal to the format we specified above. We're telling our audio stream how to understand the audio data format and channels equal to channels. It's like choosing between using one ear, mono, or both ears, stereo, and rate equal to rate. This determines how quickly we're capturing audio samples, and input equal to true. We're setting up our stream to capture audio input, recording in our case. And the last one, frames per buffer, equal to chunk. Here, we're deciding how much audio data to capture at once. Now, we will use print function to let us know that recording is starting. We'll print a message on the screen, and here's where the actual recording takes place. We'll set up a loop that reads audio data in chunks and stores it in a list called frames. We've created an empty list called frames to store our audio data. Now, imagine our audio data as a jigsaw puzzle. To work with it easily, we capture it in manageable chunks. Now, we use try while loop. This is our way of telling the program to keep doing something as long as the conditions are met. In our case, the condition is true, which means always. Data equal to stream read chunk. Here, stream read chunk grabs a chunk of audio data from the audio stream. We opened earlier and frames append data. We're adding the newly captured chunk of data to our frames list. Now, even in the most exciting journeys, we need a way to exit. In our case, when we're done recording, we can stop the loop using a specific keyboard shortcut. Picture this. You're in the middle of something important, but suddenly you need to hit pause. In Python, we can do the same with a keyboard interrupt. Just like pausing a movie with a remote control, we can exit the loop gracefully by pressing a specific key combination. When you press Ctrl plus F2, also known as a keyboard interrupt, Python detects it. The code inside the except keyboard interrupt block runs, which contains pass. Pass is like saying, it's okay, just move on. Time to finish up the recording session. We'll stop the stream, close it, and thank the microphone for its hard work. Before we wrap things up, let's tell our user that the recording has stopped. Imagine pressing the stop button on your music player. That's exactly what we're doing here. And closing the audio stream is like unplugging a device after you're done using it. Lastly, it's like turning off the lights when leaving a room. We're cleaning up by terminating audio resources. Last step, we're going to save our recording as a file. Think of this like saving your drawing as a picture. We'll create a WAV file, set its properties, and write the sound we captured into it. Let's start by deciding what we want to name our saved audio file. Think of it as giving your artwork a title. We're naming our file Recorded Audio. Now, we're creating a special place to store our audio data, just like preparing a canvas for your art. We're opening the file in write mode. Think of this step as setting the stage for your masterpiece. We're defining how the saved audio should look and sound. We're setting the number of audio channels and setting the sample width. Lastly, we're setting the frame rate. And it's time to transfer your audio creation onto the canvas. We're writing the actual audio data to the file. Last but not least, let's take a moment to celebrate. We'll announce that your audio masterpiece has been saved. We're printing a celebratory message. We have completed writing the code for voice recorder. Now it's time to record the voice. We will run this code and we'll start the recording. There you have it, folks. Recording started. Now it's time to stop the recording by pressing Ctrl plus F2. There you go. Recording stopped and saved. And there you have it. We've successfully walked through every line of code to create a simple voice recorder using Python. It might seem like a lot to take in, but don't worry. Programming is like learning a new language. With practice, it becomes more natural and fun. And for more Python programming videos, please subscribe to our channel. Remember, this voice recorder is just the tip of the iceberg. You can explore countless possibilities, adding a user-friendly interface, saving recordings in different formats, or even implementing voice recognition. The key is to keep experimenting and building upon what you've learned here. I hope this tutorial helped you understand the basics of working with audio in Python and boosted your confidence in programming. Whether you're a complete beginner or a seasoned coder, never hesitate to explore, ask questions, and challenge yourself. Thanks for joining me in this adventure, and